So basically, if I want to compare two things in their enthalpy changes, I want to make sure that they're at the same, under the same conditions, right? And that gives us the idea of standard enthalpies. Okay. So if we were to talk about the standard enthalpy change of a reaction, okay, the standard enthalpy change of a reaction. Okay, the symbol that we use is this, delta H theta. Okay, this, whenever you see this theta over here, it means that the reaction was carried out under standard conditions. Okay. Now this is the enthalpy change when molar amounts of reactants okay, as shown in the stoichiometric equation okay, stoichiometric react to form products under standard conditions. And by standard conditions we mean 298 Kelvin, okay, and 1 atmospheric pressure. If, for example, let's take an example here, okay, let's say that I have the equation nitrogen and hydrogen react to form ammonia, right? You guys are familiar with this, the Haber process, right? The delta H for this reaction is minus 92. Okay. Now, what if I wrote 1 mole of ammonia here? Then it would be negative 46. Okay. Now, the idea, guys, here is this, kilojoules per mole. The idea here is this, that obviously both the equations are balanced. Upar wala bhi equation balanced and niche wala bhi equation balanced. So if you were writing just the chemical equation for the reaction, they would both be acceptable. But when you're writing an equation representing an enthalpy change, okay, the enthalpy change represents, or the enthalpy change is specific to the amounts shown in the equation itself. So here minus 92 means for 2 moles of ammonia, I have an enthalpy change of minus 92 kilojoules. If I was forming just 1 mole of ammonia, then my enthalpy change would be minus 46. So generally speaking, जब आप chemical equations लिखते हैं, when you write chemical equations, it's okay to balance them either way. But when you're writing a chemical equation for a specific enthalpy change, the equation should represent the molar quantity being used. Over here, the theta represents standard conditions. Okay, 298 Kelvin and 1 atmospheric pressure. 298 Kelvin भी कह सकते हैं, 25 degrees Celsius भी कह सकते हैं. 1 atmosphere is not the same as 100 kilopascals. 1 atmosphere is around 1.01325 kilopascals. 101.325. Okay. I'll write this down. 1 atmosphere is about 101.325 pascals. Obviously. So now we have the standard enthalpy change of formation. Okay, the symbol that we use for this is delta H theta, because it's standard conditions, and formation ke liye it's the symbol F. Now, what is the standard enthalpy change of formation? It is the enthalpy change the enthalpy change when 1 mole of a substance, okay, is formed in its standard state from its constituent elements. In their standard states under standard conditions. So an example of a standard enthalpy of formation is this, right? So let's see. For example, let's say I wanted to write the standard enthalpy of formation of something like calcium carbonate, right? Calcium carbonate की standard enthalpy of formation में कैसे लिखूंगा? Well, so my product is calcium carbonate, and by definition I have to show the formation of 1 mole of calcium carbonate. 1 mole of a substance is being formed, right? So इसके constituent elements क्या हैं? Calcium, right, plus carbon plus oxygen, right? And we have 3 oxygens here, so 3/2 O2, right? And this equation represents the formation of calcium carbonate. And since it's the standard enthalpy change, calcium would be solid, okay? Carbon is in the solid form. The standard form of carbon is taken to be graphite. The standard form of carbon is taken to be graphite, and then oxygen is in the gaseous form, and calcium carbonate is in the solid form. So here, this equation represents the standard enthalpy of formation of calcium carbonate. 1 mole of a substance or 1 mole of calcium carbonate is being formed in its standard state, which is solid, from its constituent elements, calcium, carbon and oxygen, in their standard states under standard conditions. So whenever you're writing the equation representing formation, then it would be this. अगर आपने for example 2 calcium carbonate लिखा होता, that would be 2 times the enthalpy of formation of calcium carbonate, because enthalpy of formation is specifically for formation of 1 mole of a compound. Okay. Let's say I wanted the formation of, let's say formation of ethanol चाहिए थी मुझे. Ethanol क्या होता है? CH3CH2OH, right? C2H5OH. Now ethanol standard state में क्या उसका form होता है? उसका standard state क्या होता है? Liquid. Ethanol is liquid under room conditions, right? And इसकी standard enthalpy of formation would be, well, carbon, right? How many moles of carbon do we have here? 2 moles of carbon. So we have 2 moles of carbon, which are solid again, right? You can write solid or you can write graphite in parentheses, they accept both, okay? But you should know that carbon in its standard state is graphite, okay? Then we have how many moles of oxygen? Half a mole of oxygen gas, right? 1 mole of oxygen atom. So in the standard state, right? And we have 6 hydrogen atoms, so that's 3H2, right? So this equation represents the enthalpy of formation of ethanol. Okay. Again, carbon is solid, oxygen is gas, hydrogen is gas. Just a few notes here. The delta H of formation is usually exothermic. Okay. Sometimes it can be endothermic as well, and most reactions are exothermic in nature. So most compounds that form exothermically. It is generally used as a measure of the stability of a compound. It is generally used as a measure of a stability of a compound, right? The more exothermic the enthalpy of formation, right? The more exothermic the enthalpy of formation, the more stable the product can be said to be, right? Okay, by for example, like लेट्स से कि एक की ज़्यादा एक्सोथर्मिक है, दूसरी की कम एक्सोथर्मिक है. वी नो फॉर अ फैक्ट कि जिसकी ज़्यादा एक्सोथर्मिक है, इट प्रेफर्स being in the compound form more than the constituent elements. जितना ज़्यादा formation exothermic होगी, उतना compound formation prefer होती है और element formation कम prefer होती है. तो उतना compound stable है. Measure of stability of a compound. So the more exothermic, more exo means more stable. And the last thing that we have is that the delta H formation, of elements is said to be 0, is equal to 0. So the formation specifically applies to the formation of a compound from elements. Elements की खुद की formation क्या होती है? 0 होती है. Right? Yeah. So over here what we had was, we had the enthalpy of formation of calcium carbonate. Right? This equation represented the enthalpy change of formation of calcium carbonate. And this equation here represents the enthalpy change of formation of ethanol. Okay. Again, make sure for enthalpy change of formation, you always show 1 mole of product being formed or 1 mole of a compound being formed. Agar 2 mole honge, so it will be 2 times the enthalpy change of formation. This is per mole of compound formed. Okay. All right. The next standard enthalpy that we have, is the standard enthalpy change of combustion. Right? Now, similar to formation, we've already seen combustion before, right? The only difference in this definition is that you have to specify the conditions. So, standard enthalpy change of combustion is the enthalpy change, and I'll write down the symbol as well. Okay, the symbol here is delta H combustion, but now we use a theta to show standard conditions. Right? This is the enthalpy change when 1 mole of a substance, okay, in its standard state, okay, is combusted in, or not combusted, see, this is a mistake, is completely combusted in excess oxygen, okay, to form the combustion products, right, will be formed, but we have to make sure that the products are also written in their standard state, to form products in their standard state. Okay, and this is under standard conditions again. Under standard conditions. Right? The standard enthalpy of combustion is always exothermic, right? Always releases heat. Right? So for example, let's say we had this example here, right? Let's say that I took propane, right? Propane is C3H8 combusting an oxygen to form carbon dioxide and water, right? Now here what we have is, in this equation, propane, किसी को पता है क्या state होता है propane का? Propane is a gas, okay? Oxygen is a gas, carbon dioxide is a gas, and then water is a liquid, right? So you would write, again, standard states में 25 degrees Celsius at room temperature basically इनके क्या वो होते हैं states, right? Now by definition you are definitely combusting how many moles? 1 mole. So the equation that represents the combustion of propane, you have to have 1 mole of propane being combusted, okay? And then now you're forming 3 moles of carbon dioxide because you have 3 carbons here, 4 moles of water, And then you have what? 3.5. 4 plus 6. 3 times 2, right? So here 3 times 2 is 6 plus 4. So we have 5 O2. Okay. So again, you have to for combustion you have to show 1 mole of a substance being combusted. Okay.